we will solve the given system of three equations with three unknowns using an augmented matrix by writing the matrix in reduced row echelon form using the TI-84 graphing calculator. We're also told if the system has an infinite number of solutions to express in terms of the parameter t. So the first step is to write the augmented matrix. When we have a system of three equations with three unknowns, the augmented matrix will be a 3x4 matrix where we have the coefficients of x in the first column, the coefficients of y in the second column, the coefficients of z in the third column, and the constants on the right in the fourth column. So going back to our example, notice how in the first equation we have x plus 2z equals 4. There's no y term, and therefore the coefficient of y is 0. Or we can think of the equation as x plus 0y plus 2z equals 4. We do have to have a coefficient for each variable. Looking at the first equation now, because the coefficient of x is 1, the coefficient of y is 0, the coefficient of z is 2, and the constant on the right is 4, notice the first row of the augmented matrix is 1, 0, 2, 4. Looking at the second equation, the coefficient of x is 3, the coefficient of y is 1, the coefficient of z is 4, and the constant on the right is 2, giving us the second row of 3, 1, 4, 2. And then for the third equation, the coefficient of x is 15, the coefficient of y is 5, the coefficient of z is 20, and the constant is 7, giving us the third row of 15, 5, 27. The next step is to enter the augmented matrix in the TI-84. To do this, we press second x to the power of -1 to go to the matrix menu, right arrow twice to edit. Let's enter the matrix in matrix A, so we press enter. Next we enter the dimensions, but this is a 3x4 matrix which is already entered, so we press enter, enter, and now we enter the elements and press enter after every entry. So we press 1, enter, 0, enter, and so on. Next we go back to the home screen by pressing second mode for quit, back to the matrix menu by pressing second x to the power of -1, right arrow once to math, up 5 times to RREF, which is reduced row echelon form, enter, back to the matrix menu, select matrix A, which is already highlighted, so we press enter, close parenthesis, and enter. And now we have the matrix in reduced row echelon form. Let's record this on the screen. And again, remember the coefficients of x are in the first column, the coefficients of y in the second column, the coefficients of z in the third column, and the constants are on the right. But notice in the bottom row we have 0, 0, 0, 1, which would give us the equivalent equation 0x plus 0y plus 0z equals 1, or 0 equals 1. So notice how the equation does not contain any variables, and this equation is false. 0 does not equal 1. Whenever this happens, this indicates the system has no solution. And when there's no solution, we know we can classify the system as inconsistent. I hope you found this helpful.